Good morning, students. Today we are going to see histology. So this is a class of histology for medicine first year student. Today we are going to see connective tissue. It is a new chapter that we are going to see today, so have attention. Previously we have seen tissues and the types of tissues. There are how many major types of tissues? Four. So we have seen epithelial tissues, muscle tissues, nervous tissues, and the connective tissue. So connective tissue is one of the major tissues which differs from the other types of tissues in number of characteristics. We have said that previously all the tissues are composed of cells except connective tissue. Connective tissue is composed of cells and other material. This material is named as extracellular matrix. So, connective tissue is simply composed of what? Cells plus extracellular matrix. What is the main function of this connective tissue? As you understand from the term connective means attaching together, supporting, structural supporting. The other it serves as medium for exchange of nutrients and the wastes between blood and the tissues, so that simply we can say it is used for transport. The other it is used for protection, like physical and immunological protection, because there are a cell composed of, there are a cell which form tissues, and these cells like white blood cells they are used for protection. The other, there are cells which are used for storage of fat, so we call it as a reserve energy for the body. The other, heat generation, like Brown said, hemopoiesis, production of blood cells composed formed in bone marrow. So bone is one of the connective tissue. The other, so we simply you can say binding together for compartmentalization. Developmentally, connective tissue is composed of mesenchyme, that is mesoderm, except head mesenchyme, neurocrust cells. Good. So structurally, connective tissue is composed of what? Three main classes: cell and extracellular matrix. Extracellular matrix, when we say it composed of fibers and the ground substances. What are these fibers? It is not cell fibers. Don't forget here, cell fibers and the protein fibers are quite different. So the fibers which form connective tissue are protein fibers. These are collagen, reticular, and elastic fibers. The other is ground substances. These ground substances are like ext- other special types of structure which form connective tissues, like we can say ground major three ground substances. These are glycoaminoglycans or GAG, proteoglycans and the proteoglycans and the glycoprotein. There are major three. Fibers predominantly composed of collagen, as we have said. Mainly it is found in tendon, aponeurosis, capsule of organ, and the membranes that envelop central nervous system, like meninges. Not in organ, it is in the membrane, don't forget. It is not in central nervous system. It is found in structure covering central nervous system. So it is found not in the brain. It is found in the membrane covering of the brain. That is meninges. So extracellular matrix, one we have say ground substances. These are colorless, transparent, gel-like material that fills the space between cell and the fibers. Don't forget. Therefore, the cells are not attached to each other like epithelial tissue. What we have seen in epithelial tissues, their major characteristics are they are attached to each other, forming an uninterrupted layer. But here, cell to cell is not attached. Between cells and the cell, there is a ground substance. Between cell and the fibers, there is a ground substance. The other, it is composed of, as we have said, like glycoaminoglycans, GAG, proteoglycans, and the glycoproteins. They act as a lubricant and help us prevent the penetration of tissue by foreign particles. If you remember when we discussed even in growth anatomy, membrane of the body, there are major three membrane of the body. What are these? Mucous membrane, serous membrane, and the synovial membrane. What is the main function of synovial membrane? It is produce synovial fluid, which is a lubricant. Look, don't forget. a lubricant. Lubricant, when we say, it is used for lubrication. So this ground substances, one special contours of these fluids. That's why we say synovial is not epithelial. Synovial membrane is what? It is a connective tissue membrane. It is not epithelial. That's why. The other, it is soluble in most of the solvents, therefore it's not visible in ordinary tissue sections. When we come to this glycoaminoglycans, ground substance 3, one is glycoaminoglycans. Previously, it is named as acid mucopolysaccharide, which is composed of a linear polysaccharide formed of repeating disaccharide units, usually composed of uronic acid and hexose. The other is hexosamine, can be glucosamine and galactosamine. And the uronic acid can be glucuronic and isouronic acid. With the exception of hyaluronic acid, these linear chains are bound covalently to protein to form proteoglycans. Don't forget. So glycoaminoglycans, or simply we call it GAG, it form proteoglycans except one. Which one is it? Hyaluronic acid. The other four, totally there are 5 subunits of glycoaminoglycans. From these 5, except hyaluronic acid, the other are bound together to central protein to form proteoglycans. What are the other 4? Like chondroitin sulfate, dermatan sulfate, keratin sulfate, and heparan sulfate. From 5 group of glycoaminoglycans, which one is not form proteoglycans? Hyaluronic acid. Don't forget. Hyaluronic acid is the major components of synovial fluid, which fills the joint cavities and the vitreous body of the eye. But this is structural composition and distribution of glycans in connective tissue and their interaction with collagen fibers. Here you can say glycoaminoglycan group. Hyaluronic acid is there, chondroitin 4 sulfate, chondroitin 6 sulfate, derma. They are different. And their structure again, structurally what they looks like, and their function and distribution again. The other is proteoglycans, second one. So we have said proteoglycans simply composed of what? Glycoaminoglycans and the protein. Glycoaminoglycans or polysaccharide group is more, about 95%, but only 5% is a protein, centrally located protein. Therefore, the 4 group, what we have said, like dermatan sulfate, chondroitin sulfate, keratin sulfate, and the heparan sulfate, which are glycoaminoglycans, they attach to central protein covalently and they form proteoglycans. Good. So observe this structure. Have you seen the arrows, how it is going downwards? These arrows is the central protein. A bristle-like structures from lateral side. These are polysaccharides, the 4 glycoaminoglycans. In general, look, observe them. It is not branched, it is straight. That's why we say linear types. But when you observe the group here on B, is it straight? No. It is one, it is branched. The other, it is a globular. So this is a glycoprotein. So glycoprotein is not striated. One, it is a globular protein molecules, which is a branched chain of monosaccharide are covalently attached. So this is the main structural difference between them. Don't forget. A, it is proteoglycans, 95% is carbohydrate, only 5% protein. But when we come to glycoprotein in B, structural difference, not straight, not linear. One, it is globular and branched. The other component, it is more protein and less amount of carbohydrates, which is opposite to that of proteoglycans. So glycoprotein, already we have said that it is multi-adhesive glycoprotein in which mainly the protein mainly use predominates and these molecules do not contain linear polysaccharide. Already we have said this one. They contain branched and globular. Good. They play an important role not only in interaction between neighboring adult and embryonic cells, but also in adhesion of cells to the other. Mainly, they are used for attachments. Do you remember when we discussed about epithelial? Epithelial are resting on connective tissue. What's found between them? Basement membrane. One component of this basement membrane is, yes, what? Collagen fibers, we have said, if you remember. The other, glycoprotein. So this is simply used for attachment. So it's one special component of basal lamina. Don't forget the major three components of basal lamina that we have discussed previously. Good. So it is used for radiation like fibronectin, like laminin, which are component of basal lamina. Observe structurally what fibronectin looks like on the left side. When you observe that of laminin trimer, look what laminin trimer looks on the right side. So these are their structural components which are used for attachments. Don't forget, both of them are components of basal lamina. The other is fibers. Fibers traditionally we can classify into three, or by system into two. If it is simply traditionally into three as collagen fibers, elastic fibers, and reticular fibers, or into system, collagen system and elastic system only. Collagen fibers mainly located where tensile strength is needed, where strength is needed in the body. Elastic fibers where elasticity is needed. And the reticular fibers, rete means network, where special network or supporting framework for the cell is needed. So we can simply classify like this. Observe, collagen fibers is the main collagen fibers is collagen type 1, and the average of diameter of this is about 75 nanometer. So collagen fibers is the most abundant protein in human body, representing about 30% of this dry weight when you compare with elastic fibers and reticular fibers. The collagen of vertebrates comprise family of more than 25 members, like collagen type 1, collagen type 2, type 3, up to 25. But we are going to classify this based on their structure and function into four. The first one is collagen that form long fibrils. The second one is collagen which form short fibrils or fibril associated collagens. The third one is collagen that form network, and the fourth one is collagen that form anchoring fibrils. Collagen that form long fibrils, as you understand from the term long fibrils, means those which have long fibers, like collagen type 1, type 2, type 3, type 5, type 11. From this, type 1 is the most common. Where is the location of this? Mainly they are located in bone, in dentin, tendon, organ capsule, in dermis. Second one is fibril associated collagen or collagen that form short fibrils. They form short fibrils which are used to attach collagen fibers to one another and other component of extracellular matrix. Collagen to one another and the collagen to other component of extracellular matrix, like collagen type 9, type 12, 14. These are fibril associated or those which form short fibrils. The other are collagens that form networks. Molecules of network forming collagen or type 4 collagen assemble in measure that constitutes a structural component of basal lamina. Maybe if you remember when we discussed about basal lamina, one special component of basal lamina is collagen type 4 because it forms special networks. The other is collagens that form anchoring or attaching together. Anchoring collagen is collagen type 7, is present in anchoring fibrils that bind collagen fibers to basal lamina. Collagen fibers, when we say that of connective tissue to basal lamina, collagen type 3 to basal lamina. Therefore, based on their structure and the function distribution, based on this, we are going to classify collagen fibers into four groups. Collagen, when you observe the formation of the collagen, it is composed of tropocollagen subunit, which consists of S3 2 alpha 1 and 1 alpha 2. As you observe here, there are S3, those which are repeating from each others. Each complete turn of helix span distance of 8.6 nanometer, as you observe from the figures, and the length of each tropocollagen molecule is 280 nanometer, and its width is about 1.5 nanometer. Observe the stage of the formation of collagen. There are about major 5 stages. And in the first, the arrangement, the result of production of alternative lacunar and overlapping regions. The first one, observe it. There is overlapping regions, and this overlapping arrangement result in production of alternative lacunar and overlapping regions, so that it causes cross striation. That means you remember when we discussed about muscles, there is area of white in the dark, alternative or predically dark in the light span, which are coming together and form aggregates of fibers. Then these aggregates are coming to form bundles, and finally on number 5 it form collagen fibers. So there are major 5 steps. Collagen type 3 usually does not form bundles. Don't forget this one. From all collagen type 3 does not form bundles. Observe structurally. Maybe if you observe in tissue slide, can you identify collagen fibers from elastic? Yes, collagen fiber 1, it is strong. Second, it is not anastomosing. But when we come to elastic fibers, it is very dark, very thin, and it is anastomosing fibers. So easily you can identify in which collagen fibers is used for structure and elastic fibers is used for elasticity. Reticular fibers are simply types of collagen fibers. Collagen type 3, which is very thin and it have high sugar contents. Look, when you compare with collagen fiber, it contain about 6 to 12 sugar content or hexose, but collagen fiber contain only 1. Due to this, it is named as PAS positive, periodic additive positive. The other, it is very thin, so you cannot stay in ordinary sectioning. So you need other extra reagents, that is silver. So it is dissolved in the silver, so that's why you observe or visualize. Due to this, again, it is named as argyrophilic silver laughing, what we call it. Therefore, don't forget the two special events. Two special characteristics of reticular fibers: argyrophilic and PAS positive. Good. So observe reticular fibers, what it looks like. Reticular, we have say rete, network forming. So look, they are forming a network around the red blood cell, around the central vein of the liver. This is the liver, what you observe, and observe the reticular fibers, how they are attaching to each other, how one is forming a network with the other. The other is elastic fibers. Elastic fibers are a coiled branched fibers which is very thin again in diameter, from 0.2 to 1 micrometer in diameter, so which sometimes form a loose networks. Its main function is elasticity. So during if there is a force, it is stretched. When there is a stimuli, it has ability to stretch even more than, it is double of its weight, about 150% of their resting lengths. So mainly you will find them in arterial walls, in interalveolar septa, bronchioles, vocal ligaments, ligament flava of vertebral columns. So their main function is elasticity. Elastin in development we can classify into 3 based on their contents of what we call it protein fibers. The first one is oxatalan, which do not have elastin fibers, so it is not elastic. The second one is have irregular arrangement of elastin, that's what we call elaunin. And the third one have special orientation fibers, so it is elastic fibers. So oxatalan is the first, second is elaunin, the third one elastic fibers. Observe the fibers, arrangement of the fibers in when it is fine elastic fibers and the coarse elastic fibers. Good. So their main function is, we have said, stretching. So observe it, stretching and relax. When it is stretched, what it looks like. When it is what we call it relax, what it looks like. Look the direction when you stretch them, they look like this one. So they increase the diameter. Good. So connective tissue, they have major characteristics. This connective tissue consists of individual cells scattered within extracellular matrix. That means connective tissues are not attached to each other. The other cells of connective tissue are not directly attached to one another. unlike epithelial tissues. Individual connective tissue cells are normally separated from one another by what? Extracellular matrix. And the connective tissue are derived from mesenchyme, unlike most of epithelial tissue are from here, from ectoderm and endodermis. So don't forget this one. The other is connective tissue cells. Connective tissue cells, broadly, we are going to classify based on their location as resident cells and immigrant cells. Resident cells means sometimes we use resident cells means those which are not moving or not transporting from one area to the others. Residential, resident. But when we call it immigrant cell or wandering cells means they can move, they are motile, they are moving from one area to the other. So most of the resident cells like fibroblasts which form fibers. Fibroblasts form fibers in the ground substance. Adipocyte cells which store fats in the heat generation. Mast cells, those which are used for inflammation. Macrophages which ingest and remove foreign materials. These are some of the examples. Immigrant cells are, we can say, all white blood cells or leukocyte cells like lymphocyte, monocyte, neutrophils, those which are used for what? Immune defense and inflammation. Good. So fibroblast we can simply classify into active fibroblast and quiescent fibroblast or fibrocytes. So when we compare both of them, observe on the left side is active fibroblast. It is very large. It have more organelles. But when we come to here, it looks like the spindle. It have not more. So sometimes we call it quiescent, or simply we can say fibrocytes. And during injury, they can revert themselves to active fibroblasts. The other pericytes are derived from undifferentiated mesenchymal cells and they may retain a pluripotential role of embryonic mesenchymal cells. So these are smaller than fibroblasts and are located mostly along the capillaries, pericyte. That's why we say peri. Adipocyte cells, based on their location, we can classify into two as unilocular adipocyte cells and multilocular. Uni means within a cell, one adipocyte cells only. Uni. So mostly this is found in the adult. Their main function is storing fat and triglycerides. But multilocular, when we say there are more small fat droplets which are found in the single cell. So mainly these are found in the infants, so that their main function is heat generating. Good. The other special cells here is mononuclear phagocyting system, MNP. Mono, one, nucleus, phagocyting system. So these are different cells coming together, and their main function is phagocyting. But they have different name in different organ, like Kupffer cell in the liver, microglial cells in central nervous system, Langer cell in skin, osteoclast cell in bone, dendritic cell in lymph node, monocytes in blade, macrophages in connective tissue. So these are generally named as what? Mononuclear phagocyting system. So please don't forget this one. I will ask you this one by one. Like maybe I will ask you cell types. Maybe I will ask you their location and their function. Identify where is the location of monocyte in blade, in macrophage where, Kupffer cell are where, microglia where, Langerhans dendrocyte. So don't forget them. The other are lymphoid cells. So lymphoid cells means simply you can classify as T lymphocyte, B lymphocyte, and null cells or naturally killing cells. So T and the B lymphocyte cells, uh, they have determinant on the surfaces so that they have memory cells, but natural killer cells have no memory cells. So they are simply cytotoxic activity against tumor cells totally, whether it is used to the body or no, totally naturally killing. But when we come to B and the T, they have memory cells. Plasma cells means simply it is activated B cells which are responsible for humoral immunity. The other are mast cells. Mast cells means activated basophils which produce like heparin, histamine, serine, eosinophil, and the neutrophilic chemotype factors, different leukotrienes, C, D, E, different kinds, in which the molecules produced by mast cells act locally in paracrine secretions. The other are granulocytes, those which have granules. While they say which have granules, there are neutrophils, eosinophils, and basophils. And like neutrophils, they are going to kill bacteria, digest, and phagocyze. Eosinophils, major function of this is surface to kill simply parasites like helminths, and then release cytotoxins that damage the parasites. Good. We have said that these cells are moving, not simply resident to one areas, so that they are crossing the wall of blood vessels. This is what we call it diapedesis. They migrate through the wall of capillary and the postcapillary venules from the blood to connective tissue by a process called diapedesis. So diapedesis means simply penetrating the wall. Inflammation is a vascular and a cellular defensive reaction against foreign substance, in most cases pathogenic bacteria or irritation chemical substances. So you know that inflammation, there are a cardinal sign of inflammation. There are major five, like swelling, pain, whether it is painful or no, whether it is hot or no, whether it is functional or no. There are major five, so don't forget these major five. uh, like even it is found on your handout, so refer from your handout. The other is connective tissue types. There are major connective tissue types, like connective tissue proper, special connective tissue, and supportive connective tissue. Connective tissue proper means loose connective tissue and dense connective tissue. Loose connective tissue means which have less amount of fibers. Dense means the density is high, more fibers are there. So more fibers means less amount of cell and less amount of ground substance. But in loose connective tissue, don't forget, more amount of cell, more amount of ground substance, but less amount of fibers. Dense we can classify based on the arrangement as regular and irregular. Regular means if they have a definitive orientation, but irregular means if they have no. The other special, like adipose tissue, are there elastic and hematopoietic, which is used for blood cell production in the mucous tissue, like those which are found in umbilical cord, jelly-like structure in umbilical cord. We call it like mucous tissues. The supportive cells are cartilage and the bone, and we will come to it. This is some figures simply to identify elastic fibers. How can you identify elastic fibers? How can you identify collagen fibers? Which one is very thin? Which one is branching? Identify this already, as I have told you. Just you can observe it here again. Even here is a nucleus of fibroblast there. Collagen fibers is there. Elastic fibers is there. I will ask you on the slide. In the slide, how can you identify them? The other is simply here connective tissue, dense connective tissue. Look, arrangements, regular orientations. But when we come to those irregular one, they have no regular. Have you seen zigzag like? They have no regular orientations. The other are supportive, like bone in the cartilage. Next, we will come to the other with supportive connective tissue, cartilage and the bone. See you for today. If you have question, please don't forget to write me on WhatsApp. Thank you very much. Bye.